right, we are going to be taking notes on 8.3. And our goal for today is to use trig ratios to find a missing side of a right triangle. All right, so these trig ratios that we're working with today are only applying to right triangles. They are not to all triangles. So it's very important that when we think about this, it's only going to work with right triangles. Okay, so the hypotenuse is obviously going to be a hypotenuse. And you guys know where to find that across from the right angle. And we can abbreviate it. So it's across from the right angle. It's always going to be the same. So when we're talking about these side lengths, it changes depending on which angle you're referencing. And the hypotenuse is always going to stay the same. So that's just something to note, that this one always stays the same. Where these two are going to change depending on the angle given. So when we are talking about the opposite side, this is always going to be one of the legs, and it's the leg that is across from the given angle. The adjacent, which adjacent means next to, is the leg that is next to or touching the given angle. So we're going to take some time to just practice identifying the hypotenuse, opposite, and adjacent. So this first one says that it's coming from angle A. So I'm going to look at angle A. This one, if I'm looking for the hypotenuse, that one's easy. It's always across from that right angle. So if we go across from the right angle, we're at that side A. So side A. However, that's across. That is the opposite side. There is no opposite and adjacent leg on this one because we're talking about the right angle. Both of these legs are adjacent to the right angle, so we couldn't choose which one would be opposite and which one is adjacent. So because of that, we cannot go from the right angle. So this is actually not possible. We would not be given a problem from the right angle. Or we wouldn't be able to use trig ratios in order to solve this triangle. By solving the triangle, finding all three angles and finding all three sides. So we'll write out why. Because the sides C and B are both adjacent and there is no opposite. Okay, so that's why. Now let's go from angle B though. So if we're talking about from angle B, so this is the angle we're talking about. Which side is the hypotenuse? Now that's the one that's always easiest. I would always recommend filling out the hypotenuse first because you're going to find the right angle, go across from it. Our hypotenuse is A. So I'm going to label that here, hypotenuse. Okay, now we're talking about from angle B though. So if I want to find the side opposite, I have two legs here. I have C and B. Which side is opposite is the small b side. And I'll write that on here. So this is the opposite, which means this last one must be the adjacent, the one that's touching or right next to angle B, which is side C. So our adjacent side is side C. Go ahead and pause the video and try to do the last example on your own. So you're going from angle Z, find the hypotenuse, opposite, and adjacent. So go ahead and pause the video and do that now. Take a look at what you came up with versus what I came up with. How did it go? we were going from this angle Z. So this side here would be your hypotenuse across from that right angle. Across from side Z, or from angle Z is side Z, that's your opposite, leaving this side here to be your adjacent. Get used to labeling them because you're going to want to get used to that. Once we can actually label these, we can actually then use SOHCAHTOA. This is going to be a phrase that you are going to use quite a bit for the next couple of weeks, SOHCAHTOA. In this SOHCAHTOA, S stands for sine, C stands for cosine, and T stands for tangent. So SCT stands for sine, cosine, and tangent. Now, the way that this is spelled is actually important. This word means absolutely nothing if you can't spell it. Because what the O is then, the O is always going to stand for the opposite. The A will always stand for adjacent, and your H will always stand for your hypotenuse. So if you take sine of an angle, okay, this theta just represents an angle. We'll write that out as well. So that way you guys have that. This sign here is just a cursive O. It's called theta. It's just a Greek letter. It's used as a variable, used to represent an angle. Okay, so sine of 30 degrees or sine of 50 degrees or sine of 60 degrees. It's an operation you can do on your calculator. So that's what I'm talking about right here, sine of an angle. It's an operation on a calculator, but how you come up with that value is by doing, and if you look over here at SOHCAHTOA, it's SOH, so it's O over H. It's a ratio. So this is O over H. And then cosine, because of CAH, is going to be A over H, that ratio. Ratio is just a fraction. And tangent of theta is the fraction O over A. And the way that I can memorize these, sine is O over H, cosine is A over H, tangent is O over A, because SOHCAHTOA spells it out. S is O over H. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I can fill all of these in order to do that. You're probably like, well, how does this even help us? So if we go to the next page, we're going to do a couple examples and actually figure out how we can figure out what these measurements are. Okay, so tangent of x. The first one, we're just going to find the value of each trig ratio. And by the value of it, we're just going to fill it out. So this first one is saying tangent of x equals. So tangent of, you have to take tangent or sine or cosine of an actual angle. So it's giving us an angle here. The angle is x. So remember, up at the top, we need that word, SOHCAHTOA. Remember, it's important that you know how to spell it, otherwise it's not useful. Since the tan is the T, that means that I know that this is going to be O over A. Okay, so what I'm going to do is from this angle X, I need to label which side is going to be my opposite, adjacent, hypotenuse. Across from the right angle is my hypotenuse. Across from the X will be my opposite. And then next to the X is going to be my adjacent side. So what we know here is that tan of X is equal to the opposite was 28 and the A was labeled 21. That's your main goal here, is to do the setup. Okay, that's all I really want you to do here. You could also reduce this fraction and say that tangent of x is equal to 28 over 21. 7 goes into both of those. So if I divide the top and the bottom by 7, I am left with 4 over 3. So this would be your final answer there. But if you can get to at least this step, This is kind of your big idea here, okay? So either of these would be acceptable for what we're doing right now, okay? So let's try one more, and then I'll have you guys try one on your own. So this cosine, we know that cosine of z has to equal a over h. So that's going to be our setup based on SOHCAHTOA. So we're looking at z, so we're going to have to label O, A, and H, which side's the opposite, hypotenuse, and adjacent. So I always label my hypotenuse first because I know really well how to find a hypotenuse because we've been practicing that for a couple weeks now. So there's my hypotenuse. So now we just have 21 and 28. I have to figure out which side's the opposite, which side is the adjacent. This is going to be the side opposite. This one here will be the adjacent side. So then what I can do now is I can fill out cosine z is equal to A is 28 and H is 35. Again, if I can reduce this, I will. Cosine z, 7 goes into both of those also, so we would have 4 over 5. So that would be my final answer. Go ahead and hit pause and try that second or the third example. I know those are numbered wrong, but try that last example on your own. See if you can figure out how to label from sine of x. So we have first, you're going to be looking at angle x here. So label O, A, and H, figure out what sine of x has to equal what ratio, and do the whole setup. So go ahead and hit pause. So here is what I did. I labeled my O, A, and H over here from angle x. Notice it was not the same as this one up here because I was going from angle Z up here. It was the same triangle, but I was going from a different angle, so my O and my A are going to change places. So you got to be careful. Sine of x is equal to opposite over hypotenuse because sine is opposite over hypotenuse. My opposite, the side that was labeled O, was 28 over the hypotenuse was labeled 35. And then I reduced that fraction to get sine of x is equal to 4 over 5. Okay, so that's how we're going to do those setups. Now we're actually going to work at finding a missing side. Okay, so again, we're still going to have to use the SOHCAHTOA. So I'm going to write that word out because we want it there in our back pocket. And again, you need to know how to spell it, otherwise it's not very helpful. All right, so they gave you an angle measure here. And remember I said you can't find an opposite and adjacent if you are going from the right angle. So you're never going to go from the right angle. So here we're going to have to go from this angle 16. So across from the right angle we have the hypotenuse. Across from the 16 we have our opposite, which leaves this side here to be the adjacent. Okay. Now, we don't really care about the adjacent right now because it's not labeled and we're just finding x. We just need to find that missing side. So, which trig function deals with O and with H? Sine, S-O-H. So, sine of, and this time I'm actually going to use the measure they gave me. So, sine of 16, that sine of 16 degrees is equal to O over H. Now, fill in what you know. We don't know what O is, but we do know that it's representing X. We have H. H is actually 18, so we're going to fill that in. So there we go. Now what we can do is we can solve for X. So what I'm going to do is, to get X by itself, I'm going to multiply both sides by 18. My 18s go away here. And when I go to type this into my calculator, it's really important that you make sure that your calculator is in degrees. So the mode has to be degrees. If you're using one of the purple calculators from the classroom, in the screen it should say DEG. If it does not say that, then up at the top there's a DRG button. If you click on that, it says it has a menu and you can either click on RAD, RAD, or degree, which is DEG, the abbreviation. Just make sure you select degree. Or you can reset your calculator if you have one of those, and it should reset. So everyone needs to make sure they're typing this into a calculator right now, because if your mode is set up differently, if it's set into radians versus degrees, you're going to get wrong answers. And we need to make sure everybody knows how to use their calculator to get the right answers here. So now that we all have our calculators set up, we know that x is now alone. We need to just type into our calculator 18 times sine of 16. There should be a sine button right on your calculator. And when you type that in, it actually gives you that x is approximately 4.96. So go ahead right now, type that into your calculator and make sure that that's what you're getting. Okay. If you don't have a scientific calculator that lets you type it in this order, then you're going to have to type in 16, hit the sine button. It'll tell you what that ratio is, and then multiply that by 18. Okay, that would be the order you type it in. But if you just use one of the calculators from the classroom, it's going to be way easier, I promise. Okay. All right, so let's try this next one. This next one, we're talking from this angle 46. So let's label across from the right angle. There's my hypotenuse. Across from the angle that was given is my opposite, which means this x is the adjacent side. So we're dealing with O and A in this case because we're trying to find x and we're already given the opposite side. So which trig function uses O and A? Tangent. So tangent, the angle I was talking about was 46, is equal to O over A. Now let's fill it in. So O is actually 7. And A is x. Okay. So what you're going to do is we need to get x out of the denominator because we're not trying to find 1 over x, we're trying to find just x. So what you can start with is by multiplying both sides by x. Okay, so then what we have now is x times tangent of 46 is equal to 7. But we're trying to get x by itself, so now we're going to have to divide both sides by the tangent of 46. Now, tangent is this is a function, so these go together. You can never separate them. Okay, you can't divide by 46 and leave tan by itself. Tan is nothing unless you actually are taking it with an angle. Okay, so the tans go away on that side, and we are left with x equals 7 over tangent of 46. That you can type right into your calculator, so go ahead and do that now. And round to the nearest hundredth. And what do you guys get? You should get 6.76 approximately. Okay. Now there's no way to find your exact values here. Technically, this is your exact value. So where we were writing the radicals and simplifying before, we're not going to be doing that in this section. Okay, we're just going to find the approximate values in this section. Also, you'll notice that from the original setup, so from this original setup, x and tangent of 46 actually just switched places. So if you look at what we started with right here and what we ended up with, tangent of 46 and x actually just switch places. So you're allowed to do that shortcut and just switch those places if that makes more sense to you. But I did still want to walk you through how they switch places and showing all your work on that. But if you show me this setup and go directly to this, that is totally fine too. I want you to try to do the setup and solving of number 3. And so go ahead and hit the pause button on the video and try to do number 3 on your own and then hit play to see how we did. All right, so what we did first was we said we have the angle measure 63. Remember, you can't go from the 90. So I use that 63 to label O, A, and H. Once I had those labeled, I realized I don't care about O. I'm looking for the trig function that uses A and H. So A and H, I use the cosine because of CAH. So cosine of 63 degrees is equal to A over H. A was 23 over H was X. I noticed it was using this same idea from number 2. So I just switched the cosine 63 and X because I'm going to multiply both sides by X and divide by cosine 63. So this is what I typed into my calculator, and I got 50.66. So now you guys can work on the 8.3 assignment. And if you take a look at the assignment, numbers 1 through 8, all you're going to do is set up the ratios just like we did up here on these first 3. So set up the ratios and then reduce if you can. 9 through the end, so 9 through 20, you're going to work like we did in these last 3 examples where you're going to find a missing side. Okay? Let us know if you have questions.